All right, we're going to start lesson 2.3 today on solving multi-step equations. Okay, we've worked on solving the one-step equations. Now we're going to add a little to it. Um, this process I'm sure you've done before. It's not going to be anything new, but we really need to work on showing our work as we solve these problems and making sure that we're given the details needed as we go through these. Okay, so the first kind of question you're going to get tonight is basically this. We understand that the solution to an equation is the value that will make the equation true. And our first question is they give us a two-step equation and just say which of these, if any, are a solution to the equation. So when we're given a situation like this, what we're really going to do is take these y values they're giving us of 9, 1, -4, -5, and we're going to substitute them into our equation and see if it makes it true. All right, so our first one is let's let y equal 9. Well, if y equals 9, then this equation becomes 5 times 9 plus 7 equals -13. 45 plus 7 equals -13. 52 equals -13. That's a false statement. So this value of 9 did not make the equation true, so that's a no. Try our 1. So let's let y be 1. We'll start all over again. 5 times 1 plus 7 equals -13. 5 plus 7 12 equals -13. That's a false statement as well. That's not true. So 1 does not make our equation true. Let's let y equal -4. So take our equation, substitute in the -4. We're going to get -20 plus 7 equals -13. And we get -13 equals -13. That's a true statement. So -4 is a yes. It makes our equation true. And then we'll try the last one. You've got to know which ones do and don't make it. So you got to try all these. So we'll go 5 times -5 plus 7 equals -13. -25 plus 7 is -13. -18 equals -13. False statement. So that's a no. So this is just a little bit of let's make sure we understand exactly what we're trying to do here, which is to find which one of these values are going to make it true. And we do that by substitution, showing a work. Okay, today as we solve multi-step equations, I got a basic three-step process for us, and it varies from equation to equation, but this is pretty true. It's something that you can follow as you do any kind of an equation problem, any kind of a solving of equation problem. The first thing we always want to do is simplify each side of the equation. So, the equal sign divides our equation into a left and a right side. We want to make each side as simple as we can before we start to try to solve it. So what does that mean? Well, distribute if we can distribute. And if we have like terms on the same side of the equal sign, let's put those together also. So we want to get everything simplified first. And then we got to isolate the variable term. So we got to identify which term has the variable in it, and we got to get it by itself. And generally, we're going to add or subtract to eliminate a number to get the variable term by itself. Once we've done that, we got to make the coefficient of the variable term a 1. So the coefficient is a number multiplied by the variable term. So we need to make it a 1 by dividing, by multiplying, or by multiplying by the reciprocal, which is what we do with fractions. Okay, so there's our three-step process. And I'll continually kind of talk our way through this as we solve these different equations. Okay, so our first example here, this is a little two-step equation. Okay, 66 equals 4y plus 14. Our objective is to find the value of y that's going to make this true. Now, I always like to solve equations left to right. So what I did is use the symmetric property of equality to interchange the two sides. So I moved the 4y plus 14 to the left and the 66 to the right. Okay, that's still a balanced equation. The left and the right are equal. So if I switch them, they're still equal. All right, now we'll go to work on solving. So is the left side simplified? Well, I have two terms and they're not like terms, so I can't add them together. So yeah, the left side is simplified. The right side is one term, can't do anything with that. So yes, our equation is simplified. We're ready to go. Next step is to isolate the variable term. Here's my variable term, 4y. I want to get it on this side by itself, so I got to eliminate this. So the way we're going to eliminate it is we're going to subtract 14 from 14. 14 minus 14 is 0. That's going to make this a 0. 4y plus 0 is 4y. That isolates the 4y. Now, whatever we do to the left, we do to the right. So we're now going to have 4y equals 52. Again, show balance on each side of the equation. At this point, I've got my variable term isolated on the left. Now I want to make the coefficient here become a 1. So I got to make 4 become a 1. The way I'm going to do that is to divide each side by 4. So 4y divided by 4, the 4's will cancel into a 1, and I'll get 1y or y. 52 divided by 4 is 13. There's my answer. Y is 13. If I take 13 and plug it back in place of this y and simplify this, it will be 66 equals 66. Okay, our next one over here, again, a little two-step equation. I already have the variable term on the left. I like it to have it on the left because I like to work left to right. So look at my equation. I got two terms on the left, -6 and 5u. They are not like terms, so I can't combine them. On the right, I got -21. I can't do anything to make that any simpler. It's just one term. So now I start going to work. I want to isolate 5u. The way to do that is to make this become a 0. How do I make -6 become 0? Add +6 to it. -6 plus +6 is 0. Got to add 6 to the right. The result of this step will give me 5u equals -15. Now I want to make the coefficient here become a 1. Since u is being multiplied by 5, if I divide it by 5, division undoes multiplication. That will cancel out there, and I'm going to get u equals -3. Okay, pretty straightforward process, but you got to understand the steps. You got to be able to write it. If we can't write and show work for the simple ones, we're not going to be able to do the tough ones. Okay, another one. This is just a little variation here that makes it a little different. Okay, and I'll go through this with you here. So if you look at the left side of the equation, you got two terms. You got 40, and really it's the opposite of w, or -w. And then on the right side is 262. So I can't do anything to make it simpler. So I'm going to work to isolate my variable term. Now that minus sign is attached to the w, not to the 40. So if I'm going to make 40 become 0, I got to subtract 40 from it. So I got to subtract 40 from the left side, and I'm going to subtract 40 from the right side. Now 40 minus 40 is 0. That's why we did it. And notice that this minus sign will still be in front of the w here. So I'm going to get the opposite of w equals 222. Now, the technical way we do this, is we understand that this really means -1 times w equals 222. Okay? That opposite of w is really -1 times w. So at this point, I want to make my coefficient, which is -1, become +1. So how do I make -1 become +1? Well, you can divide each side by -1, or you can just multiply each side by -1. What's -1 times -1? +1. So that will give me w, and then this will become -222. So you got to keep track of the sign in front of my variable because it stays attached to it, and we got to deal with that throughout the problem. Next example uses decimals. Just a little change up here, so it's not a whole lot different. If you look at our equation, the left side of our equation is -11.1. That's only one term, so there's nothing I can do to simplify that. The right side of my equation is w divided by 6 plus 8.1. This is really two terms. This w divided by 6 is a term, and this 8.1 is a term. They're not like terms because this one has a variable w in it, this one doesn't. So there's nothing I can do to make it any simpler. So we're ready to start solving. Okay, this w divided by 6 is my variable term, so I want to isolate it. How are we going to do that? Well, I guess the first thing I did is I put I interchanged the two sides, which is called symmetric property, because I like to solve left to right. Okay, again, my w over 6 is my variable term, so I want to make this become a 0 right here. So I'm going to subtract 8.1 from both sides. 8.1 minus 8.1 is 0. That's going to leave me with w over 6 over here. This is going to give me -19.2 on the right. Remember, a negative minus 8.1 becomes plus -8.1. So that's a negative plus a negative, really. Okay, now w is being divided by 6. I don't want w divided by 6. I want just w. So what undoes division by 6? What's the inverse of that? It's multiplying by 6. So w over 6 times 6, what happens here are the 6's are going to cancel because this is really like 6 over 1. So I can cancel and I'm left with w. And on the right side, I got to multiply -19.2 times 6. And that should be a negative, guys. That should be a -115.2. I missed a sign there. Okay. So it's the same process. We just threw some decimals in. Okay. Now what we want to look at are fractions. So what happens if I got an equation that involves fractions? Well, really, this is a two-step equation. Okay. But what we're going to do is we're going to work on getting rid of fractions in an equation like this today. It's a pretty handy little tool to have, and it really makes it slick so that you don't have to deal with fractions, because a lot of us don't like to do that. All right. So my equation is -1/2 times x plus 1/5 equals 2/3. Okay. What we want to do in our first step is eliminate all these denominators. So what we need to do is to identify what is the least common multiple of 2, 5, and 3. In other words, what's the smallest number that 2, 5, and 3 will all go into evenly. Okay. So you got to look at some factors here. Uh, the answer is 30. Both, or excuse me, 2, 5, and 3 will all go into 30 evenly. And the reason we need to choose that is because we're going to multiply both sides of our equation by that number. And because 30 is divisible by 2, 5, and 3, all of them, it's going to eliminate these fractions for us. Now let me show you how this looks. So what we're going to do here is we're going to multiply the left side. Notice I put it in grouping symbols because I want to multiply both of these by the 30. On the right side, I'm going to multiply the 2/3 by the 30. Okay. Now I'm going to think of that 30 as 30 over 1, which any whole number is over 1. And we're going to distribute it through this parentheses. So it's 30 over 1 times -1/2 x. That's the first part of it. And then 30 over 1 times 1/5 equals this. I wrote 30 over 1 times 2/3. Okay. So the reason we did it is for this right here. We're going to cross cancel. 2 goes into 30 15 times. 2 goes into 2 once. We can cross cancel. And if I multiply what's left, it's 15x. The 1 in the denominator becomes this all is all over 1, which is just the number on top. Look here. Next one, 30 over 1 times 1/5. The 5 and goes into 36 times, goes into itself once. So the denominator now is all a 1. So I got +6. And over here, do my canceling. I get 10 because 3 goes into 30 10 times. 2 times 10 is 20. So now what we've done is work this into a two-step equation where there are no fractions anymore. It's just all whole numbers. This equation that we've written here is the same as this equation. Those are equivalent equations. They are the same, but this is a whole lot easier to simplify or solve. So let's go ahead and solve this one. So our first step is to isolate 15x. So we're going to subtract 6 from both sides. 15x equals 14. Divide each side by 15 to get my x to have a coefficient of 1. This will cancel out the 15s and give me a coefficient of 1. And I'm going to get x equals 14/15. Okay, leave it like that. You don't have to make it a decimal. Leave it. That's the easy, simple answer. It's reduced. It's acceptable. Leave it that way. Okay, so we're going to work this process today. Let's do another one. So I got 3 over 2 minus 3/7 x equals -4/3. We want to eliminate the fractions so I can work with an equation that has no fractions in it. So 2, 7, and 3. We got to find the smallest number that 2, 7, and 3 all go into evenly. Okay. So if you think of like the multiples of 7, 14, well, 2 will go into 14, but 3 won't. 21, well, 3 will go into 21, but 2 won't. 28, 2 goes into it, but 3 won't. 35, neither one goes into. 42 is the number that all of these will go into. So we're going to multiply both sides by 42. Remember, guys, as long as we multiply the left side and the right side by the same number, it's equivalent. So I'm going to take the 42 on the left side and I'm going to distribute it, multiply by each of these. And I'm going to make it a number over 1. So 42 over 1 times 3 over 2 plus 42 over 1 times 2 over 7 equals 42 over 1 times -5/3. And now we go ahead and do the simplifying, and we know it's all going to cancel out because we set it up that way. So let's start with our first product here. 2 goes into 42 21 times. 2 goes into 2 once. So now I no longer have any numbers in my denominator except ones. So it's going to be whatever I get when I multiply the top. Here, 7 goes into 42 6 times. Goes into itself once. 6 times 2 is 12x. 3 goes into 42 14 times. 3 goes into 3 once. 14 times -5. Don't miss that negative sign. Is oh shoot, I did miss it. It's -70. Okay. Now we're ready to solve this thing. All right. So I got 12x. I want to isolate the 12x. So I'm going to subtract 63 from both sides. And guys, I did mess this up. This should be a -70. So forgive me there. But you could. I'm going to do it as is, but you can make that correction. All right. So if I subtract 63, that's a 0. If I subtract 63, that's a 7. Divide each side by 12, and I get 7/12. We all know that's not quite right because I missed the sign right here, right? So you guys can hopefully make that correction without me. So we are going to work some of these today too, where I give you fractions in here and you eliminate those. All right. So we're going to work on two-step equations. We're going to work on getting rid of fractions in an equation and solving what remains. That's what your homework is focused on. Remember, you've got to show work. You got to write the equations out and you got to show step by step. That's going to be critical to what we're doing. And I will be looking at that when you turn in your homework. All right. I'll let you get at it.